Welcome back to another Walking Talking Mock. This is another Further Maths Paper 1. This is June 2013. And we've got a curve has gradient function dy by dx equals 9 minus x cubed. Work out the gradient of the curve when x equals minus 1. So we're going to do 9 minus 1 cubed. Minus 1 cubed is minus 1, so I've got 9 minus 1, so the answer is 10. Work out the value of x, where the rate of change of y with respect to x, rate of change of y with respect to x is just another way of saying dy by dx. So work out the value of x when dy by dx equals 1. So if dy by dx equals 1, that means 9 minus x cubed equals 1, which means that minus x cubed equals minus 8, which means x cubed equals 8. I was one step ahead of myself, which means x equals 2. We've got a circle, diameter. Work out the coordinates of the centre of the circle. Well, the centre is in the middle of the diameter, so I just need to find the midpoint of these two. So the midpoint of minus 4 and 2 is going to be, if I add them together I get minus 2, and half it I get minus 1. And the midpoint of 3 and 11, add them together is 14, half it is 7. Minus 1, 7. And then work out the radius of the circle. Okay, so let's go back to this. So I could work out the length of the diameter and then just half it. So the diameter goes minus 4 to 2, that's 6 across, and then 3 to 11 is 8 up. So that's going to be 10. Well, okay, let's do it properly. 6 squared plus 8 squared, square rooted, will be the diameter. So that's 36 plus 64, which is 100, so that's 10. So the radius is going to be 5. So the equation of the circle, well, if the centre is minus 1, 7, then it's going to be plus 1 and minus 7 there, and the radius is 5, so 5 squared is 25. So it's that. So remember, the sign inside there is the opposite of what the centre is. Okay, P is another point on the circle. The gradient of the line A to P is 2. It's on the circle somewhere, and the gradient is 2. Okay, wait, what's the gradient of this? 8 divided by 6 is 4/3, is it? Which is like 1.3 recurring, so it's steeper than this. Okay. Oh, wait, P is there. I was wondering where to put P, and they drew it on for me, so that's stupid. Okay, the gradient of that is 2. What else do we know? Write down the gradient of the line P to B. Well, you should have spotted that this makes a triangle in a semicircle, and a triangle in a semicircle has a 90-degree angle. So if that gradient is 2, and this is at a right angle to it, it's perpendicular to it, the gradient must be minus a half. Okay, what's next? We've got a right angle triangle, okay. Tan x is 2/3. Okay, so I'm going to have to use tan somehow. Work out the length of B to C. Okay, let's label this H, A, O. So I want B to C, so I'm going to do tan x is opposite over adjacent. Tan x is 2/3. Opposite is 4, and adjacent we don't know. Okay, well if 2 over 3 equals 4 over something, then A is going to have to be 6. Because it has to be double. Okay. Work out the length of A to P. Okay. Well, I can't work that out, but I could work out that. But the angle there is not x. The angle there is x, so I'm going to have to use that angle instead, which means I'm going to have to relabel this because things are different now. So now this is the hypotenuse, this is the adjacent because it's with the angle, and this is the opposite. So now tan x is the opposite over the adjacent. Oh wait, I know what that is, that's 6. Yeah, 6 over the adjacent, which I don't know. Okay, and tan x is 2/3, so 2/3 equals 6 over A. So A is going to have to be 9 for that to work, because that's times 3, so that's times 3. If that's 9 and that's 4, then that bit there must be 5. Solve. Ooh, interesting. We've got a bit of a nest, like a nested square rooty thing. So I'm going to square both sides and take away 33. And then square both sides, so x is 9. Which you can kind of just see actually, because the square root of something to equal 6 is going to have to equal 36, 33 plus 3, so that's going to have to be 9. Okay, show that that simplifies to that. Gladly. Right, now you might be thinking you need to expand this, because you can't factorize it. I mean, it doesn't look like there's a common factor. There isn't a common factor. However, you can spot something. Can you spot anything here? I'm trying to give you a clue. Yeah, it's the difference of two squares. Because it's something squared minus something squared. So I can actually, pretend this was like a squared minus b squared. That becomes a plus b. A minus b. So x plus 7 is like the a, and the x minus 3 is like the b. And then x plus 7 minus x minus 3. I'm putting brackets there to remind me that I'm doing minus minus here. So I've got 2 x's and 10. And then I've got x minus x is nothing, and then I've got 7 minus minus minus. So cute. Minus minus 3 is going to make 10. Okay, which is it's almost that. Okay, there's a common factor of 2 here, so let's just pull 2 out. And there we go. That's the answer they wanted. Let's put some equal signs here because I'm a disgrace to my profession for not doing equal signs. And look, they're even lined up. Oh, wait, there's a question here I almost missed out. Good job it's not a 10 marker on Pythagoras. Hence or otherwise work this out. Now, you have to spot how this relates to this. So how is 107 going to be related to x plus 7? Well, if x was 100, then it would be related. And if x was 100, then x minus 3 would make 97. So can you see that it's the same sort of thing? So instead of using the complicated version, let's use the simple version that we've just proved by putting it into there. So put x in place of x. So what's 20 times 105? It is double it, is 210, and then stick some zeros on. Oh, wait, just one zero. That, 2100. Simplify. So I'm going to do 3 to the power of 4, which is 2781. X to the power of 4, and y to the power of 5 to the power of 4, which makes 20. Expand and simplify that. Okay. So I've got y squared times 2y. I got y squared times minus 3. I got minus 5y times 2y. I got minus 5y times minus 3. Was that squared? No. I've got 2 times 2y. I got 2 times minus 3. And now let's collect the like terms. So I've only got those cubes. I've got those 2 squares. I've got those 2 y's. And I've just got that on the end. And I can't simplify that anymore. Oh. Sorry, I'm just yawning. The curve has that equation. Work out dy by dx. Easy peasy. Work out the equation of the tangent to the curve at the point, so right, tangent, same gradient, to the curve at the point where x equals 2. Give your answer in the form y equals mx plus c. Okay, so first let's work out the gradient by using dy by dx and putting in x is 2. 2 cubed is 8, times 4 is 32, minus 20 equals 12. So y equals 12x plus c. We need to substitute a point into that. They haven't given us a point, they only gave us the x because they are stingy. So if x is 2, what's y? X to the power of 4 minus 5x squared plus 9, okay. So that's 2 to the 4 minus 5 times 2 squared plus 9. That's 2 to the power of 4, 16. Minus 20 plus 9, which is 5, I think. So the point is 2 and 5. So I'm going to substitute 5 and I'm going to substitute 2. So we got 5 is 24 plus c. So c is minus 19? Yes. No. Yes. Yeah, c is minus 19. There we go. Solve this quadratic. You know what I haven't done in ages? Solving a cubic. That wasn't on the last paper I did. Maybe that comes up on calculator. I don't know why it would come up on calculator paper. Oh well. Let's solve this. Okay, they want me to leave it as a surd. That is a clue that it's not going to factorise, so I'm not even going to bother. I'm going to need to do either completing the square or the formula. I prefer the formula, although this is quite a nice completing the square one. Shall I? Yeah, you know what? I'm going to complete the square because it's going to be a nice one. So if I half that, I'm going to get that. If I just expand that out, I'm going to get that. But I don't want that, I want that. So I need to take off 2. So I'll just write that over there. And that has to equal 0. So I'm going to add 0 to both sides. Ignore this thing. Wait, did I just say add 0 to both sides? Yeah, let's do that. Okay, I'm going to add 0 to both sides. Done. Right, now let's add 2 to both sides, because that's much more sensible. Square root both sides. Of course, whenever I square root, I'm going to be putting plus or minus. And then take off the 3. And I think I wrote it backwards. Yeah, I did. Okay, so let's write it the other way around just to keep them happy. And there we go. That kind of looks 3D. That was not intentional, but that looks cool. Now, make x the subject of that formula. Okay. That's times both sides by a minus x. Then let's expand that. And because I want x the subject, I'm going to get all the x's onto the same side and all the other stuff onto the other side. And then I'm going to factorise the x out to separate it. And then finally just divide so that I'm just left with x. Like that. Whenever you've got two x's in a fraction and it wants you to make x the subject, you are going to need to factorise at some point. Here is a sketch of a cubic. Oh, yay! I'm hoping I get to do polynomial long division. Oh, it's told us the roots already. 3 linear factors of f of x. So it's the opposites of the roots. So we've got x plus 5. We've got x plus 0. I'm not writing x plus 0. That makes me look stupid. I'll just write x. No need for brackets. And then x minus 3. You are given that f of x is x cubed plus something x squared plus something x. Look at the values of b and c. Okay, well that's easy. I know the factors are this. So now I just have to expand that out. And then that will give me that. So I'll expand, I'll ignore the x for now and I'll just expand this guy. Simplify that a little bit. And then let's put the x back in. And let's just put an f of x on the front there. There we go. So b is 2, c is minus 15. Oh, I didn't get to do long division. Rubbish. Work out all. Why have they bolded that? That's clearly it's going to be quadratic. Work out all solutions for x and y if this matrix. Okay. So I'm going to times out this side here. So x times x is x squared. And 3 times minus 4 is minus 12. 1 times x is x, y times minus 4 is minus 4y. And that has to equal this. I don't know why I've written this so big. Okay, so x squared minus 12 will have to equal 4x. And then I've got another equation which has got y in it. Let me just split the page because I'm going to need lots of space. I can't solve the equation with y in it yet because this equation doesn't have y in it, it only has x. So I could solve this by itself to get x, and then put that in there, and then try and solve that. Okay, so this is a quadratic. Will it factorise? Yes. I can use 6 and 2. Minus 6 plus 2. So x is 6 or minus 2. That's equals, not a minus. Okay, so let's put 2 options. So 6 minus 4y equals 8, or it could be minus 2 minus 4y equals 8. So if I solve this one first, 2 by 6 divided by minus 4. And then solve this one. So add 2 divided by minus 4. I don't know why I decided to make that one a decimal. Okay, so the answer is x equals 6 or minus, no, I should put them in pairs. So x equals 6 and y equals minus a half, or x equals minus 2 and y equals minus 2.5. I put them in pairs because you need to know which x goes with which y. They're going to be picky about that. Okay, that's going to be the end of part 1. I will see you in part 2 in a short moment. Bye!